Alright, welcome to note set number 2 for this unit, the notes on proving triangle congruence. So, in the previous lesson, we learned there are 5 conditions that we can use to prove two triangles are congruent. They're congruent if they have side, 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 meaning 3 sides that are all the same, side, angle, angle, side, angle, 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 side, or hypotenuse leg if it's a right triangle. Remember, hypotenuse leg was only for right triangles. So, we have a quick little flow chart on proving that two triangles are congruent. So first of all, I have to decide which one of these do they have. Well, they have a side that's congruent, then an angle, then a side. So it's SAS for side, angle, side. So in order to prove it, I need 3 circles because I have 3 things to prove, a side, an angle, and a side. So I have side, angle, side, which then at the end I'm going to be able to prove because of side, angle, side. Remember, what I'm trying to prove is that my two triangles are congruent, which means I'm trying to prove that triangle RLN is congruent to triangle. And remember, when I write my congruency statements, the letters have to match. So R was the one that was at the end of the 2-liner, but not a part of the angle. So at the end of the 2-liner is C or A, but A is a part of the angle, so it's C that goes with R. L was where the angle was, so L is A in this one. And then N is the one at the end of the 1-liner, so that's B. Okay, remember, I'm going to be able to say that because of these 3 facts. And if I'm listing side, angle, side, I need to do it in that order. It needs to be side, then angle, then side. So, the first side that's the same is NL. N to L is congruent. Remember, congruent is an equal sign with a little tilde above it. 2, N, remember we just said was B, the same as B. And L is the same as A. And it's a side, so it gets that line. And I know that because it's given. This tick mark here, this 1 tick mark, is them telling me it's a given fact that those are the same. Then I have this angle. This angle is RLN. RLN draws it when I go in that order. And it's the same, and remember, they have to correspond correctly. R was with C, so it's congruent to angle C, and then A, and then B. R went with C, L went with A, and N went with B. So C, A, B also draws that angle over there. And because it's marked with a little tick, it's just given to us. That is a given fact. Okay, so I did my side, then my angle, then I have my next side, my side with the 2 tick marks. So LR, side LR, is congruent to side. LR is the same as AC. And because of the tick marks on them, it's just a given fact. And so now I have proved with a flowchart proof that my 2 angles are congruent. Or my 2 triangles are congruent. So, if you go ahead and flip it over, there's a few things I have to tell you. So sometimes when we do these, you'll have 2 triangles that end up sharing a side. For example, it might look something like that triangle with that triangle. So a shared side is when the 2 triangles share a side. Just like this line right here is a shared side for both of them. So a shared angle is when the 2 triangles share an angle. So a picture of that might be something like this. This angle right here, they're both sharing. The smaller triangle has it, and then the tall triangle also has it. So, for both of these, the proper definition, the proper name of it is called the reflexive property of equality. Reflexive property of equality. And basically all that is big words to say shared side or shared angle. When you do proofs, you could use either shared side, shared angle, or you could say reflexive property of equality for your reason. Just know that they mean the same thing. On the test, they'll probably use that. Okay? And then finally, angle bisector. An angle bisector is a line that cuts an angle perfectly in half. It's a line that cuts an angle perfectly in half. So if you have this angle right here, and let's say the whole measurement is 80. If I have an angle bisector that comes through and cuts it perfectly in half, so that would be my angle bisector. That means this little angle would be 40, this one in here, and then that one there would also be 40, because it cuts the 80 perfectly in half. And so why this matters, because when you're trying to prove congruency, if you have two triangles that are split by an angle bisector, then you can say that this one's equal to that one. And you know that because of the angle bisector, and that would be your reason.